Edwards, and this is my Physics 2211 Lab 1 on constant velocity. The purpose of this lab is to utilize Tracker and Glowscript to follow the momentum and position of a real-world object and predict its position in the future. This lab uses Newton's first and second law in order to calculate and predict velocity over time and observe constant velocity. The concepts used are Newton's first law, which states an object in motion tends to stay in motion unless acted upon by another force, and Newton's second law, which says that force and acceleration are proportional through the equation net force is equal to mass times acceleration. The lab setup includes an orange, which I found the mass of to be 0.184 kilograms, a diameter, which is 0.08 meters, and an origin at the center of the orange with the x-positive axis pointing to the right. My initial calculations were found to be initial time equal to 0 seconds, initial position equal to negative 0.00385 meters, final time equal to 1.635 seconds, and final position equal to 0.506 meters. The delta t was equal to 0.033 seconds per frame shown in the video. There was a slight technological/human error in placing the origin, hence why the initial position is not exactly at 0. The tracker data shows the lab setup of rolling an orange across the floor in the positive x direction. The coordinate system is shown in hot pink with the orange starting near the origin. I cut out the first few seconds in order to leave out the force possibly created by my initial push I gave the orange. As it rolls, its center of mass is recorded via red dots for every timestamp point. As you can see to the right, data points are created and are used to construct a position time graph that is constant within Tracker. These are my initial calculations for initial velocity. Velocity is known to be change in position over change in time, so I took the initial position and I subtracted it from the new position found at the first timestamp recorded. So the new position was found to be negative 8.011 times 10 to the negative 4 minus negative 3.845 times 10 to the negative 3 over the new timestamp of 0.033 seconds minus the initial timestamp of 0. This was found to result in 0.0922 meters per second as the initial velocity, and these numbers came from my tracker data. My Glowscript code, I edited slightly from the given code to use the radius of my orange, which was half the diameter of a standard orange, 0.08 meters, also the mass, which was found to be 0.184 kilograms, and I also found the starting point of the orange relative to the origin, and then use this along with the change in position and time to find the initial velocity as shown in the last slide. I also updated the while loop to run until the final recorded time from Tracker, 1.635 seconds, and also updated the position and velocity update formulas to contain the values that will be updated over time to reflect the change in velocity and position of the orange relative to the variables used in code. Once running the code, a constant position time graph and constant velocity time graph are produced, which coincides with our observed data. The following graphs show my computed versus observed data analysis. The first graph shows the position versus time graph for my computed data through Glowscript. It shows a constant slope, which indicates the constant velocity, and also an r squared equal to 1. This graph shows my position versus time graph for my observed data. This has a slightly less constant slope, but it's still a trending constant, and has small variations possibly due to friction and human error and force in using the exact center of mass in Tracker. It has an r-squared value of 0.976. When comparing these two on a graph, there's only small differences between the two. The computational model is able to predict the observed model pretty well. What if we were to flip the axis, i.e. x becoming negative x and vice versa? This would show that slope would have the same magnitude but opposite sign as shown in the graph. The initial position theoretically shouldn't change, but due to my origin placement error, there is a slight discrepancy. It shows that it would basically flip the observed x data. What does this mean? It means that the computed model is able to predict the force is equal to 0. This is not accurate in the real world, i.e. there's air resistance, friction, and other things we don't consider at this point in class acting upon the object. So it's impossible to analyze the push and pull that's actually occurring in this system. In the real world, having no friction is impossible, so it is only possible to estimate the net forces acting upon the object and confirm Newton's first law within this lab. Thank you for watching.